Hello everyone, my name is Ellohim Milano Kuron, with student ID 24101060053. I am from the Faculty of Mathematics and Natural Sciences, majoring in mathematics, under the Information Systems Study Program, Class B. Today, I will present a topic about resistors and three fundamental logic gates, and, or, and not. To begin, let's briefly introduce quantum computing, which transforms the classical concept of binary digits into more advanced qubits. In quantum computing, qubits represent 0 and 1 simultaneously through superposition and interact using entanglement, enabling parallel computations. This technology efficiently solves complex problems like cryptography and optimization. Moving to transistors, a transistor is a semiconductor electronic component that acts as an extremely fast switch, controlling the flow of electrical current with precision in modern digital devices. Transistors are the key components of nearly all modern electronic devices. Millions of transistors are interconnected in integrated circuits ICs, enabling data processing and storage. Transistors utilize binary logic, represented by 0 and 1, which forms the foundation of data computation in computers. Without transistors, processors and memory would not exist, making them indispensable for electronic technologies. In addition to data processing, transistors play a critical role in computer memory. Each bit of data, either 0 or 1, is stored in a transistor that is either in the on or off state. The ability of transistors to rapidly switch between these states allows computers to read and write data at incredible speeds. Transistors are also used in processors, control units, and input and output interfaces to support various digital functions. In various electronic circuits, transistors work together with other components like resistors and capacitors to regulate signals, amplify current, and filter frequencies. Without transistors, much of modern technology, including computers and smartphones, would not exist. Research on transistor technology continues to focus on creating smaller, faster, and more efficient devices for future innovations. Next is logic gates.
Logic gates are the building blocks of computer circuits. They accept input and produce output according to a set of logical rules. One of the simplest logic gates is the NOT gate, represented graphically here. The NOT gate takes a single input, either a 0 or a 1, and inverts it, so that the output is the opposite of whatever the input is. If the input is a 1, then the NOT gate outputs a 0. If the input is a 0, then the NOT gate outputs a 1. To represent the logical rule this gate obeys, we can draw a truth table, which is just a way of writing down the rules for some logical formula. This table says that if the input is 0, then the output is 1, and if the input is 1, the output is 0. Often, though, our computers need to be able to perform calculations not just on a single bit of information, but on multiple bits of information. The AND gate, shown here for example, is a logic gate that takes two inputs instead of one. Let's call these two inputs A and B. As the name might suggest, the AND gate will output a 1 when both A and B are 1s, but in all other cases, AND will output a 0. We can construct a truth table here too. This truth table is a bit bigger, since with two inputs there are more possibilities to consider. If A and B are 0, the output is 0. If A is 0 and B is 1, the output is 0. If A is 1 and B is 0, the output is still 0, and only when both A and B are 1s is the output a 1. The OR gate, meanwhile, is also a logic gate that takes two inputs. This gate outputs a 1 when A is a 1, or when B is a 1. So if both inputs are 0, the OR gate outputs a 0. But if either of the inputs is a 1, or both inputs are a 1, then the output of the OR gate is also going to be a 1. These logic gates on their own follow fairly simple rules.
In conclusion, resistors, transistors, and logic gates are the building blocks of modern electronics. Resistors regulate current to protect circuits. Transistors switch states to process and store data. Logic gates execute binary operations, forming the basis of computation. Together, they enable the functionality of digital systems, from basic devices to advanced computers. Thank you for your attention. I hope this explanation has been insightful and easy to understand.